Hello, today I'll be talking about machine learning and artificial intelligence. Just a brief introduction and how it applies to healthcare. Artificial intelligence is simply a computer capable of human-like intelligence. And then within that, machine learning is one of the ways to achieve AI. And machine learning involves recognizing patterns without being explicitly programmed to do so. And then machine learning has further subtypes called neural networks, which is biologically inspired. So there are nodes which act like neurons. And then, like in the human body, stronger the neurons, stronger the neural connections between the links that it forms. And deep learning is something that's got multiple nodes across different domains. And then again, it looks for connections across those. This is just a sort of an overall graphical view of how deep learning fits into artificial intelligence. There are also a lot of non-machine learning based approaches as well.
Programmed algorithms are already used to make decisions in healthcare, from simple triaging to giving life-changing diagnoses. These are rule-based systems, and they form an integral part of healthcare delivery across many specialties. Here are some of the examples. So in gastroenterology, there are classifications of esophagitis that is based on how far the lesion is at the lower esophageal sphincter. There's also high resolution manometry, which looks at particular parameters to classify and diagnose as well as then treat. Similarly, there's a skin lesion reporting system.
Okay, so how does machine learning work? Machine learning works by developing something called a trained algorithm. The way it does that is the machine learning algorithm is fed a set of training data, which has meaning. So, for example, in our case, we use pictures of skin lesions, their defining characteristics, and an ID to define them. And this could be thousands and thousands of images that fed into this machine learning algorithm with some meaning. And then that gives us a trained algorithm so it knows what is cancer and what is not cancer. Then this is tested. So then we'll give it some new images that it hasn't recognized, and then we'll see how well this trained algorithm performed in sorting those images into cancer and non-cancer. And this trained algorithm can then be further retrained in a cyclical manner as more and more data is generated to make the trained algorithm as efficient as possible in performing the task needed.
Okay, so the machine learning algorithm learns by several different methods depending on what the task that needs to be performed. And in healthcare, there are three main types of tasks, which is classification, regression, and clustering. So classification is when we want to sort the data to a defined set of classes. This is what we did in the skin lesions example. And there's clustering, where we give it a set of data and we hope that the machine learning algorithm finds patterns within that data set. And there is regression, which is predicting numerical outputs based on the observed patterns. Okay, so there are different types as well within this. So within machine learning, there is supervised learning, where the algorithm has a teacher and we know what the outputs are going to be. In contrast, unsupervised algorithm learning gives the algorithm the freedom to find patterns within the data set without known outputs. Gradient descent works by making random guesses and then quantifying the error to find the true value, and then gradually reducing the error to find the best fitting model by taking more targeted guesses. And this is widely used in medicine, especially on large data sets. Okay, so once we've chosen a machine learning algorithm, we have to have a set of defined performance metrics to measure the algorithm against. The algorithm is also further fed back into the machine learning algorithm to update its model and to learn the parameters that best fit the data. They're also then evaluated with normal medical metrics such as type 1 error and type 2 error. We'll find the sensitivity specificity of the ROC curves. Just a note, AI healthcare RCTs make a very tiny proportion of research published to date, with most AI healthcare being retrospective and prospective studies. There are also ethical concerns due to unknown biases. This is due to the nature of the machine learning algorithm itself, often not being explicitly programmed. It's almost a black box decision maker, and we don't know why it's made the certain decisions. However, there are guidelines being developed to ensure safe research and clinical adoption of these systems. As more and more researchers take this on, the field will carry on advancing and holds the potential for data-driven medicine that is evidence-based.
Okay, I just want to point out to this study by researchers who analyzed a lot of colonoscopies, trained an algorithm to find polyps, and then used this algorithm in real time to assist them in finding polyps that they could have potentially missed. So this can be applied to laparoscopic surgery because there's a lot of video data that can potentially be analyzed to give us data on anatomy as well as pathological structures, such as an endometriosis, for example. Recordings can also be analyzed retrospectively to aid in surgical training. And there's also scope for autonomous laparoscopic camera guidance in robotic surgery. Also, just want to highlight that the field is growing rapidly as more and more research gets carried out in this area. Okay, thank you for listening. The aim of this talk was to just give a brief introduction to machine learning in healthcare and how it could be potentially applied to laparoscopic surgery in the future. Here are some additional resources to learn more.